Welcome to a lesson with Dr. Powell. Let's take a look at a particular situation for an optimization problem. Suppose that we're trying to get from point A to point C, and we have a river here, and we want to know kind of optimally where we should put our point B to swim to before we run. It's also in order to make it from A to C at the shortest amount of time. Suppose that we can run twice as fast. This is so run 2 times as fast, which means pretty much that that as we can go over here, that pretty much means that the time will be half as much per unit distance. So pretty much all we're doing is it's the same thing as minimizing distance here to minimize time in choosing our point B. We're minimizing distance, but we're just kind of thinking about this as twice as short as it appears, and that's pretty much it. So we're going to find these lengths given a point given B, and it could depend on something. Why don't we use an angle theta for it to depend on? But we're just going to take 1/2 of whatever distance we have right here. Also, let me give some other measurements. Let's suppose that this is 1 mile across, and also suppose that that it's 3 miles downstream from here to point C. 3 miles. Okay. All right. So this length right here, let's think about how we could think of that in terms of our angle theta. See, that's a 1 mile, and so it looks like maybe cosecant theta would be equal to this. You could think, sine of this is equal to 1 over that, or you could think cosecant of this is equal to hypotenuse over 1, which is just cosecant is the hypotenuse. So we got cosecant right here. Now up here, what do we have? Well, let's think about this. This is this should be cotangent of theta. You could see that because adjacent over opposite is the cotangent. Well, the opposite's 1, so adjacent must be cotangent. So it looks like this distance right here is 3 minus cotangent theta. But if we're thinking about time, it's gonna we can kind of cut that down in half, and then just kind of use this. So if we minimize this, we'll minimize time here. So let's just minimize this function right here, cosecant theta plus 3 minus cotangent theta all over 2. Okay, now we come up with a derivative, which is negative cosecant theta cotangent theta. And for that part, and then over here, 3/2, that just goes away on the derivative. We're just left with, actually it becomes a plus cosecant squared theta over 2. Okay, then we can factor out the, let's factor out the cosecant theta. Let's just factor it out. So let's see, cosecant theta, and then we're left with, and I'll reverse the order that this is written. So cosecant theta over 2 minus cotangent theta is what we're looking at right here. Further, we could factor out a 2. And if we did that, then let's see, that would go away. And left with a 2. Oh, it's not. Actually, I guess we'd have to factor out a 1/2. Sorry, I factored out the wrong thing. Okay, we could factor out a 1/2. Sorry, factor out the 1/2, and then we have a 2. Let's see here. Okay, that's a cosecant right there. So that would be a, that's just what it is. Okay, but then the minus cotangent, then we'd have a 2 right there. Okay, that looks better. Okay, I just wasn't writing it around right. Okay, so we get 1/2 cosecant theta times that. And problem points. Well, in this particular domain where we're looking the first quadrant for theta, really. So really just probably just places where we're equal to 0 is all we're interested in. Well, I don't think we're not gonna get anything from cosecant. The only thing that we're gonna get is, because that's like the reciprocal of sine, it's not gonna be 0 anywhere in there. Um, yeah, and theta equaling 0 is out of the question. So let's take a look at this over here. Set those equal to each other. Let's see, this is basically, it's like 1 over sine theta is, okay, so we set this equal to 0 and put that on the other side, is equal to 2. We got a sine theta and a cosine theta. Notice that we can kind of ignore the sine thetas for a minute and divide by 2. We're going to get the cosine theta is equal to 1/2. And that's going to be at pi thirds. So theta equals pi thirds is the angle that will minimize the that'll minimize the time, and that is achievable at, let's see, so theta equals pi thirds, and this is 1 mile, and we just want the cotangent. Cotangent of pi thirds is 1 over the cotangent of pi thirds is 1 over root 3. So 1 over root 3 miles. Yeah, so 1 over root 3 miles downstream is kind of your point for B that you want to hit. Thanks for watching.